Okay, so good morning, guys. So today is well, it's actually good afternoon. So just want to give you some of the simple questions for the midterm. So Pre-Cal. Yeah, let me use a better color. Simple question for the midterm. Okay, so here's one of the problem. I think I did it on the earlier video. So let's say that you need to find a polynomial p of x of degree 4, and the zeros are 2 minus I and 3I, and a constant coefficient, which is 30. So basically what you need to do here, so we're using the conjugate theorem. So the conjugate theorem, that means, well, x minus the quantity of 2 minus I, that's one, well, 2 minus I, that's one of the zero. And also the conjugate, it's also part of the zero, so that means 2 plus I, it's also the zero. And also the same thing happened with that 3I. So it's 3I, it's one of the zero, that means the conjugate. So that also is being the zero. So the rest of this, that means you want to FOIL, multiply it out. We're using the difference of 2 squared formula. But don't forget the constant coefficient at the end. So for A, so that means A is going to be 30. So we try to do some of the problem like this. So multiply it out. So we do have x minus 2. Regroup them. And then negative times negative, which is positive, plus I. And then x minus 2. Regroup them. Negative times positive, negative, minus I. And this one is just the difference of 2 squared, so x squared minus 9I squared. And also this one too, difference of 2 squared, x minus 2, quantity squared, minus I squared. One thing that we notice for I squared, that's considered negative 1, so it's x minus 2, quantity squared, plus 1. Make sure that you need to FOIL this. And then x squared plus 9. Okay, so this one expanded, so you do have x squared, and then minus 4x plus 4 plus 1, then that would be plus 5, and then x squared plus 9. And then at the end, don't forget to distribute that 30. So this one here, you can just multiply it out first, and then multiply out the 30, which is the constant coefficient. Okay, so now let's see what else that we have for the rest of this. For the simple questions. Make sure that you know what to do with that P over Q, okay, the rational zero theorem. Graphing, exponential functions, logarithmic functions. Okay, let's see what else that we have right here. Compound, okay, let's go for certain formulas that you need to know. The identity. So identities that I need to know for the log properties. There are tons of them. Okay, just give me 1 sec. So when is that log base b? X times y, so it's log base bx plus log base by. I need that airplane. And then log base b of x over y. That goes log base bx. Minus log base by, and then the other one we have is log base b x above r, so that goes r log base b x. Okay, so product to sum, quotient to difference, and then power to coefficient. And make sure that you know how to apply all of them. And also another one is like log base b of x, so it's written as log x over log base b. Change the base formula. So here's one of the word problems. So let's say that you want to find out the time. So how long it takes. Okay, so how long will it take for an investment of $1,000 to double in value if the interest rate it's 7.5% per year. And this one is compounded continuously. So if that's compounded periodically, we're using that a of t. So that equals a times 1 plus r over n to the power of nt. For this one, the key word continuously, we're using the one that with per. So p, which is what? The initial principle. So 1,000. And then, okay, well, let's see. So investment of 1,000 to double, so that means the final amount is going to be 2,000. Keyword. And then continuously, so e to the power of RT, interest rate, so 0.075 times the time. And then from here, you want to solve for t. So divided by 1,000 both sides, so we got 2 equals e to the power of 0.07 t. And then take the natural log. So taking the natural log on the right-hand side, natural log of e got canceled. And then we left with 0.075 t. So that means t equals natural log of 2 over 0.075. Okay, so that's another simple problem. Okay, so now here's another one. So that's something a lot of people probably forgot. Back to chapter 1, the way to solve for the nonlinear inequality. Remember, anytime that we solve for the nonlinear inequality, we need to do the sign test or the table test. So let me show you one of those problems. Okay. There's a lot of stuff here. Okay, so here's one of those. So 5x squared plus 3x, it's greater than or equal to 4x squared plus 2. So basically what you need to do with this one here, you want to bring everything together to one side. So 5x squared minus 4x squared. And then 3x minus 2 is greater than or equal to 0. So first thing that you want to do, bring everything together to one side. So we do have x squared plus 3x minus 2. It's greater than or equal to 0. And then another thing you want to do is try to factor it. It looks like this one is non-factorable. But let me just make up the problem which is factorable. So let's change that to minus 2 here. Minus 2, then that turns out to be positive 2, positive 2. And then this one will be factorable. So x plus 2 times x plus 1, which is greater than or equal to 0. And then you want to find a 0. So that means x is negative 2. And then x equals negative 1. But don't forget, this one it's the quadratic. It's a non-linear inequality. So that means you want to do the sign test. So for the 0, we'll find out that from negative infinity to infinity. So we do have negative 2, negative 1. And then the factor we have is x plus 2, x plus 1, and then the result. Whatever the result that's satisfied, it's greater than or equal to 0. That's the one we want to check. Okay, so let's start it with the number. Any number right between negative infinity to negative 2. So we do have negative 3. Number right between negative 2 to negative 1. We got negative 2.5 or 2.5. Well, no, that doesn't work. Negative 1.5, excuse me. And then over here, 0. So negative 3 plus 2, then that would be negative 1, negative. Negative 3 plus 1, negative 2, so negative. Negative times negative, which is positive. And that satisfies the result, so that's yes. What about negative 1.5? Negative 1.5 plus 2, then that would be positive 0.5. So that's positive. Negative 1.5 plus 1, then that would be negative. So positive times negative, so then that would be negative. So that doesn't work because we need something that's greater than 0. And what about for 0? Does that work? Positive, positive, and then the result's going to be positive? Yes. So eventually the final solution for this would be from negative infinity to negative 2, interval notation. And then, well, at negative 2, then that would be a bracket because it has the equal signs. Union, and then bracket, negative 1 to positive infinity. Okay. so again, this one is like going back to section 1.6. Okay. Another thing is that make sure that you know how to do the zeros, finding the zeros with the synthetic divisions, the remainder theorem. Okay, all that. Okay, so now let's see what else that we have for this. So for the midterm, the easy way for me to grade it, it's going to be 25 problems. For the things that I would like to do the best 20. Okay, so because some of those here are like graphing calculator problem. We barely talk about the graphing calculator problem. So I just want you to select the best 20. Okay, so let's see what else that we have for this. Okay, so make sure that you know how to simplify the complex fractions. So something like this. So x over y minus y over x over 1 over x squared plus 1 over y squared. So basically this one, just find the least common denominator first. So top and the bottom, we do have x squared, y squared, so multiply everything by x squared, y squared. And then from here you want to distribute, multiply it out, distribute, and then cross cancel. So x over y times x squared, y squared, so you'll get x to the third power times y, because y goes into y squared once. Okay, so this one get canceled. X squared times x to the third power. And then minus this one here, cross cancel. So we do have x, y cubed. And then the denominator, so this one multiplied it out, so y squared plus x squared. And then the top part, we can always pick out the greatest common factor, xy. So we left with x squared minus y squared. Denominator, just leave it. And then also we can factor this one more time. So x minus y, x plus y. So it's all over y squared plus x squared. Okay. So now let's see what else. Finding the zeros. Make sure that you know how to find the zeros with that p over q. Okay, so let's do one more. Finding that p over q. Okay, so let's say we do have p of x. So 4x to the third power minus 3x squared minus 4x plus 3. I mean, for those of you who want to use that p over q, that's fine. Then that'd be like plus minus 3 over plus minus 4. So it's going to be like a bunch of fractions. A lot of possibility. You can do it that way. Another way you can do it, you can factor it, if that's possible. So try to factor it. So we group them. So 4x to the power 3 minus 3x squared. And then plus negative 4x plus 3. Yeah, that's right. So let's take out the greatest common factor for the first group. So we take out x squared. So we do have 4x minus 3. Second group, we can take out negative 1. So it's x minus 4x minus 3. So factor this once again. So we got 4x minus 3, the common binomial, and then x squared minus 1. So factor it. 4x minus 3 times x minus 1 times the quantity of x plus 1. So we get a 0, 3 over 4, x equals 1, x equals negative 1. So it's more efficient if you try to do it this way, if that's factorable. Otherwise, you have to go through the rational zero theorem, and also you need to perform the synthetic division. Another thing is that make sure that you know how to find the VA, HA. So here's another example. So let's say r of x equals x to the third power minus 4x squared over x squared minus 4. So you need to find VA and HA. So VA, so just set the denominator equal to 0, solve for x. So you got x equals plus minus 2. And then HA, so this one, the power on the top is greater than the power down the bottom. So you have to use the long division. So there's no HA, but you can find the slight asymptote. So use the long division process to find out what that is. Okay? So that's another one. Okay, so now let's see what else that we have for the simple questions. And make sure that you know how to do that, the FOG, or the f of g of h of x, or g of f of h of x, okay? So the composition functions. Okay, let me take a look at that, things that we have for the rest of this. And also the latest stuff, again, the majority of the stuff is going to be chapter 4, exponential functions, logarithmic function. Make sure that you know how to sketch the graph. The VA with the log, and the HA with the exponential function. So just watch all the video that I put up for chapter 4 lately, and also the one that we have for the midterm, the question that we just went over. Okay, so thank you for watching all the video today. So see you guys next time.